Welcome to this video supplement involving calculating limits entailing factoring. Look at the limit we have on the screen. Perhaps you want to hit pause and try it before we begin. We are going to look at a total of two problems in this supplement. But the first thing we want to remember is when we start off, just simply plug in that value of x to the expression you have inside the limit and see what happens. In this case, a negative 1 cubed plus 1 all over a negative 1 squared minus 1 is going to be negative 1 plus 1 over 1 minus 1, which is 0 over 0. And remember, we called that the indeterminate form because from that we cannot determine what the limit is going to be. But what we realize is that the value of x equals negative 1 makes both the top and bottom equal to 0. So negative 1 is a 0 of the top and bottom, means that x plus 1 has to be a factor of both the top and bottom. So we leave our limit notation out front, and then we factor the numerator and the denominator. Now the denominator is pretty straightforward, a difference of squares. The numerator, perhaps we remember the formula for the sum of cubes. If we don't remember the formula for the sum of cubes, we could always do the synthetic division. Cube squared x constant. We know that negative 1 has to be a 0, and we could just go through and do that synthetic division as we would have in the past. That would have told us our remainder, we would have had our constant, our x, and our x squared, and we could have factored that way. Now once we've factored, we can cancel the common factor, but please leave the limit notation out front. Want to see the limit notation until we plug in the value of x. So we get x squared minus x plus 1 all over x minus 1. And the reason we have that is because the x plus 1's cancel when we're doing a limit. And now we plug in the value of negative 1, so we get negative 1 squared minus a negative 1 plus 1 all over negative 1 minus 1. This is going to be 1 plus 1 plus 1 all over a negative 2, which means our final answer is going to be a negative 3/2 for the limit. Notice again that once we plug in the value of x, that's when we cancel out and get rid of the limit notation. But otherwise, fairly straightforward. Factor, cancel, plug in, evaluate. Let's look at our second example. You want to hit pause and try it before we proceed. But the first thing we want to do is plug in our value of x and see what happens. Perhaps the limit just pops out really fast and easy, and we don't have to go through a whole ordeal of factoring or other strategies. So we plug it in. In the numerator, 5 times 9 is 45. We're going to have minus 42 minus 3. Ooh, that's looking like 0. In the bottom, we'll have 18 minus 15 minus 3. So we are getting 0 over 0, which remember is our indeterminate form. It could be just about anything at this point. We need to go further and employ new tactics. So again, since negative 3 is a 0 of both the top and the bottom, we now know that x plus 3 should factor both the top and the bottom. It makes the factoring a little bit easier. Now certainly you can employ synthetic division, or you could just try to factor it. We know we're going to have a 5x. We know we're going to have a 1. We want it to be plus 14. We want it to be a minus 3. I think that does the factoring. In the bottom we'll have a 2x, and we have to have a 1. We want it to be plus 5x. We'll put a minus there. That should give us what we want. Check it, FOIL it out. It works. We cancel the common factor of x plus 3 because we don't care about what happens at negative 3. We happens about what gets close to negative 3 for x values. We've talked about open dots and how they really don't impact the limit per se. Now that we've canceled it out, we're now going to plug in negative 3, and we get rid of the limit when we plug in the value of x. Up top we'll have negative 15 minus 1. In the denominator we have negative 6 minus 1. This looks like it's going to be a negative 16 over a negative 7, which means overall our limit would be equal to a positive 16/7. So when we're trying to find a limit, really not that bad. First plug it in. Quite often you're going to get an indeterminate form. And then the first technique we talked about was looking for a common factor in both the numerator and the denominator that we can cancel and then find out what the limit actually is.